child of curiosity, 1778, early years. On December 17, 1778, in the small town of Penzance, Cornwall, England, a boy named Humphry Davy was born into a modest family. His father, Robert Davy, was a woodcarver, and his mother, Grace Millet, came from a well-respected local family. From a young age, Humphry was curious about everything around him: the colors of minerals, the smell of the sea, the sparkle of light. Though he received limited formal education, his imagination was boundless. He loved poetry, nature, and experimentation. At Penzance Grammar School, he showed brilliance but often ignored rules, preferring hands-on exploration over textbooks. No one could have guessed that this restless Cornish boy would one day revolutionize chemistry itself. The making of a young scientist. Davy's journey towards science began after his father's death in 1794. To support his family, he was apprenticed to a local surgeon and apothecary, John Bingham Borlase. Here, he discovered the wonders of chemicals, gases, and reactions. He experimented fearlessly, sometimes dangerously, producing small explosions and strange vapors that filled his room. Friends described his curiosity as uncontrollable. Davy also began reading the works of Lavoisier, Priestley, and Boyle, learning chemistry by self-study. His passion led him to write notebooks full of observations, linking chemistry with life and imagination. Even as a teenager, he believed science was not just about facts. It was about discovery and wonder. The Bristol Pneumatic Institution. In 1798, Davy's talent caught the attention of Dr. Thomas Beddoes, who invited him to join the Pneumatic Institution in Bristol, a research center studying gases for medical use. Davy eagerly accepted. There, he conducted groundbreaking experiments with laughing gas, nitrous oxide. While testing it, he even inhaled the gas himself, describing the euphoric sensation as the most pleasurable moment in existence. His self-experimentation made him famous. Davy suggested that nitrous oxide could be used to reduce pain during surgery, a visionary idea far ahead of its time. These experiments not only introduced him to the scientific world, but also revealed his fearless approach to discovery. The rise at the Royal Institution. In 1801, Davy's remarkable experiments brought him to London's prestigious Royal Institution, where he became assistant lecturer in chemistry. His youthful enthusiasm, charm, and powerful lectures made him an instant star. Audiences filled the hall to hear him speak. Not just scientists, but poets, aristocrats, and even members of Parliament. He turned chemistry into a spectacle of fire, color, and light. Davy's demonstrations transformed public interest in science. By 1802, he was appointed professor of chemistry, and his fame began to rival that of any public figure in England. His charisma earned him admirers, including a young assistant named Michael Faraday, who would one day surpass even his teacher. Discovering new elements. Between 1803 and 1810, Davy entered the golden age of his discoveries. Using electrolysis, he broke down chemical compounds to reveal new elements. In 1807, he isolated potassium and sodium, two reactive metals never seen before. The next year, he discovered calcium, magnesium, strontium, and barium. Each discovery was a triumph that pushed the limits of human knowledge. Davy's laboratory glowed with the sparks of his experiments. His use of electricity in chemistry marked the beginning of electrochemistry, a field that would later shape modern physics and technology. Davy's name, now, stood among the greatest scientists in Europe. Davy and the power of electricity. Davy was fascinated by the relationship between electricity and matter. Inspired by the works of Volta, he built massive batteries to investigate how electric currents could separate compounds. His study showed that chemical bonds might be electrical in nature, an idea that laid the foundation for modern atomic theory. In 1808, he published his famous Bakerian lecture, summarizing his experiments on electrochemical decomposition. This work not only revolutionized chemistry, but also inspired younger minds, including Faraday. Davy had revealed that electricity was not merely a force. It was a key to understanding the structure of the universe. Fame, friends, and a romantic circle. By 1810, Davy had become a national celebrity. He mingled with England's leading poets and thinkers, Samuel Taylor Coleridge, William Wordsworth, and Lord Byron. They admired him not just as a scientist, but as a philosopher-poet of nature. Davy himself wrote poetry celebrating the harmony between science and beauty. Yet fame brought pressure. He began to travel across Europe, meeting Napoleon scientists, exchanging ideas, and receiving honors from foreign academies. He was knighted in 1812 for his contributions to science, becoming Sir Humphry Davy. But fame also began to distance him from his humble beginnings. Marriage and travel in Europe. In 1812, Davy married Jane Apreece, a wealthy and fashionable widow. Their marriage gave him entry into high society, but lacked deep affection. Together, they toured Europe after the fall of Napoleon, visiting laboratories and meeting scientific luminaries. During this journey, Davy made another historic discovery, the element iodine, and studied the composition of chlorine, proving it was an element, not a compound as once thought. He also carried out experiments with volcanic gases in Italy and met great continental scientists. His fame now reached international heights, yet his personal happiness remained uncertain. The miner's lamp, a gift to humanity. In 1815, while coal mining accidents killed hundreds due to explosions of fire damp, methane, Davy turned his attention to solving the crisis. After careful research, he invented the Davy Safety Lamp, a simple but life-saving device. The lamp's flame was surrounded by fine wire gauze that prevented the ignition of explosive gases. This invention saved countless miners' lives and earned Davy enormous gratitude from the working class. However, some rival engineers claimed they had similar designs, leading to bitter disputes. Despite this, Davy's name became forever linked with human safety and practical science. Not just discovery for fame, but discovery for life. Rivalry in decline. By the 1820s, Davy's health began to decline due to exposure to chemicals and overwork. His once bright energy faded. His relationship with Faraday grew strained. Davy, now proud and aging, began to see his former assistant's rising fame as a threat. Their bond, once built on admiration, turned cold. Davy's experiments became fewer, and his lectures lost their spark. Yet his curiosity never died. He continued writing, reflecting on philosophy and nature, trying to unite science and art. Though his body weakened, his mind remained restless and searching. The final journey. In 1827, after suffering a stroke, Davy left England for the warmer climate of Italy, hoping to recover. But his health continued to deteriorate. Far from home, he wrote his final book, Consolations in Travel, 1830. A mix of science, philosophy, and poetry, exploring the meaning of life and the divine order of nature. It was not just a scientific work. It was a farewell letter to the world. Through his writings, Davy sought peace with himself and with creation. His once fiery spirit had turned into gentle wisdom. Death in Geneva, 1829. On May 29, 1829, in Geneva, Switzerland, Sir Humphry Davy passed away at the age of 50. He died quietly, away from the laboratories and crowds that once adored him. His death marked the end of an era, the age of experimental wonder that had transformed chemistry from mysterious art into a true science. His funeral was modest, attended by friends and admirers who knew that the world had lost one of its brightest minds. Davy's body rests, but his discoveries continued to live in every flame, battery, and chemical reaction that shaped modern science. Legacy of light and knowledge. Humphry Davy's influence stretched far beyond his lifetime. His discoveries laid the foundation for electrochemistry, atomic theory, and practical inventions that changed industries. His protege, Michael Faraday, carried his legacy forward, expanding on his electrical research. Davy's name was immortalized in institutions, awards, and scientific literature. But perhaps his greatest contribution was the belief that science and imagination belong together. As he once said, "Nothing is so fatal to the progress of the human mind as to suppose that our views of science are ultimate." Davy's spark of curiosity still burns, inspiring every scientist who dares to explore the unknown. The spark that never died. From a Cornish boy to a knight of science, Sir Humphry Davy's journey was a story of light, discovery, and human curiosity. He gave us more than new elements. He gave us a way to see the world as a grand experiment. His courage to inhale unknown gases, his compassion to save miners, and his poetry of nature made him a rare soul where art met science. Even today, every flame that glows in a lab pays silent tribute to the man who once played with fire to understand life itself.